In 3D video games, controlling movement feels intuitive. We turn left, tilt up, or roll sideways. These three numbers are called Euler angles. But behind the scenes, relying on them creates a catastrophic mathematical glitch. Euler angles describe rotation through three nested rings, or gimbals. First, we yaw around the z-axis. Nested inside, we pitch around the y-axis. Finally, we roll around the x-axis. Because these rotations are applied sequentially, each movement changes the orientation of the next axis. They are structurally dependent. Here is the critical failure. If we tilt the middle pitch ring exactly 90 degrees, the outer yaw ring and inner roll ring align perfectly on the same plane. Turning left and rolling sideways now perform the exact same spatial movement. We have lost a whole dimension of control. This trap is called Gimbal Lock. Mathematically, game engines multiply sequential rotation matrices, Rz times Ry times Rx. When the pitch angle, theta, equals 90 degrees, the combined matrix's terms collapse due to basic trigonometry. The columns become linearly dependent, mathematically locking our degrees of freedom. To solve this, modern engines use Quaternions, four-dimensional hypercomplex numbers. Rather than rotating sequentially around three local coordinates, a quaternion defines a single axis in 3D space, and rotates directly around it. Because there are no nested steps, Gimbal Lock is mathematically impossible. Quaternions also make transitions beautiful. Instead of jerky linear paths, game engines use slurp, spherical linear interpolation. This traces a perfect, smooth arc along the surface of a four-dimensional hypersphere, ensuring flawless, glitch-free rotations in every frame.